concept of a software bill of material plays more and more an important role as companies try to get transparency on the use of software components in their applications and systems. In this video, we want to look at how software bill of material and discovery play an important role in IT asset management.
Welcome to the JDisk YouTube channel.
A bill of material is well known from manufacturing and engineering. It's the list of parts that compose a certain piece of hardware. A software bill of material is the same, just for software. It's the pieces that make up a software or system. In today's world of cloud-native systems and microservices, systems are composed of various applications and services. Each of these services that interact with each other is again composed of software components. These components depend on the programming language used. So in the same system you might meet an application that uses Java and JavaScript for the web application, C# or PHP, Go, Python, other languages. Each of these languages has its own package manager and its own way to represent components, versioning, etc. So we want to have a bill of material for the complete system, for the complete piece of software. And for that, we need to decompose the system into its applications and its own components and generate an overall software bill of material. Now, a company will not collect this bill of material just to have a piece of data. IT asset management is really a basic function of other activities. So you want to identify all your components and have an inventory. You want to check authenticity and verify integrity of these components and check where they're from, the provenance. Why is that important? Well, on the one hand, you have open source components, not just commercial off-the-shelf components. And these open source components require that you make a documentation of the licenses that you use and the copyrights that these components use. Or on the commercial side, you might need a software license management. Or you want to enforce the reuse of components in your development organization. You might want to decompose your services and know what software it is composed of. You want to have dependency management in your software organization. You want to know what software components are contained in a certain package or distribution. Why? One topic for another one is, for example, that of security. We looked at security vulnerability management to understand whether there are any known vulnerabilities in any of the components that you make use of. And then finally, to make a risk management of your supply chain. Are there any components in there that have, for example, a malware included? It had been the case for Node.js components in the past, so that you can alert the development teams, all the other software applications that make use of this one component. So you see, there are a lot of applications of where you can make use of a software bill of material. So this is a very central concept that we need to go after here. Now, where do you get all the information that you need for your software bill of material? Well, at the lowest level you have components, open source components or commercial ones. Usually you have something like a package manager. So you can scan the project source code of your application and find out which components are used there. Your application itself might be self-development by a own development team. In this case, there might even be manual work required to create such a bill of material. Or on the level of the whole system, you might be able to scan your servers based on the file system or on package managers of your operating system, such as RPM, apt, etc., or on Windows corresponding list of installed applications. Now, because that is very heterogeneous, you will want to use a discovery system that takes over the task of looking at the various sources depending on your operating system and extract this bill of material. What you get is a set of single bill of materials for each project, for each application, for each system part. And you want to combine these into a central system. That will be your IT asset management system, the source for all these applications that we just mentioned. This asset management system can be a CMDB, but it could also be a general purpose asset management system. And this system then contains the complete bill of material. Now let me shortly point you to a small difference. Normally you have what's called is a type SBOM. That means you have a certain software which can of course be used on multiple systems. So this type of software has always the same components. On the other hand, if you're looking at the system, you have instantiation of this software on one server, another server, in a cloud environment, etc. So you have the same application running multiple times, and you have still your components that make up this application, but you have them on one or other system, so you know which system is running on. You might be interested in both information, in the composition itself, as well as where this component is running. And your asset management can provide you with both informations on all levels. Now let's get practical. We do not have to invent our own file formats for SBOM representation. There are already a couple out there. Let's name two of them. Number one is SPDX, Software Package Data Exchange, an effort from the Linux Foundation. This format is an XML representation and the specification is pretty large. It covers all information about application packages, licenses, etc. down to the file level. So it does not only have license information for the whole package, for the file, from the header of the file, also from headers of methods even. So you get a very detailed open source documentation. On the other hand, it has a nice list of licenses, so standard names for licenses, which are also used in other specifications like CycloneDX. You find more information about SPDX on spdx.dev. CycloneDX on the other side tries to be a lightweight and modern format of a SBOM specification. It has both an XML and a JSON representation and a smaller specification which concentrates on the most important artifacts of an SBOM. It uses standards like the SWID, software IDs from the ISO IEC, as well as package URLs, plurals, to represent artifacts like libraries and components. More information can be found on CycloneDX.org. Let us look at an example of CycloneDX in JSON serialization. As you see, this is a bill of material with an application and a library, and it fits on one page. It has a header which contains the specification version, information, identification information, and it has an application and the library, probably that's used in the application. As you see here, the application as a installed software is identified by a software ID according to ISO IEC 19770. The library, in this case a Tomcat Java component from some Maven repository, is identified with a package URL, PORL, which is a pretty pragmatic RFC specified standard identifier for libraries. Do we practically get this SBOM generated, as we don't want to usually write it by hand, except for cases like the application itself as one service? Well, the part below, the components, there's tooling available for CycloneDX, for example. On the CycloneDX Tooling Center, you find a lot of command line tools and libraries for all programming languages that allow you to scan, for example, a project tree in the file system, which generates you a SBOM in JSON or XML format. On top of that, for the system, you will usually use a discovery tool that accesses under the hood the operating system specific package managers. And one tool, of course, that can do that is JDisk Discovery. Now let's look at a practical example how we can get a complete software bill of material. On the one hand, we use the CycloneDX command line tools so that we can scan the file system for example, packages or components of a project. This creates a bill of material file in JSON. On the other hand, we use a discovery tool to look at our system. So in this case, it's JDisk Discovery. We run a discovery, and then we use the new GraphQL API that I have presented in a previous video in a script. In this case, a small Python script that uses the GraphQL API to extract the information, convert this list of installed applications into the CycloneDX format using the CycloneDX libraries, and we get another bill of material part. Now these two parts we load into an IT asset management system. In this case, we use a standalone asset management tool, which is called OWASP Dependency Track. Dependency Track is an OWASP open source project from the OWASP project. And in addition to being an asset management system where you can look at your bill of material, search it, crawl it, you can also identify known vulnerabilities for these components and create alerts, etc. So a nice system that you can run in a Docker container just as a sample system. Of course, there's also a wide area of commercial software and other open source software available for this task. The script that we've written in Python to do this conversion, you can find on the JDisk GitHub account as a public sample project. If you are interested in the script shown in this video, there are more of these in the JDisk GitHub repository. If you like the information in this video, we would really enjoy if you give us a like and subscribe to this channel to promote its use for other people. More videos are coming for you. Thank you very much. Your Peter.